Hello, I'm Mark Schneider, a Global Success Manager for Bentley Systems. I work with the largest and most advanced engineering firms doing digital transformation and advancement. This is a high-level overview of how we use 3D reality models for digital twins for a world where intelligent computer models don't exist. I also invite you to watch my session called Digital Twins Living in a Paradigm of Digital Transformation, where I walk through a complete life cycle of a digital twin for infrastructure. Let's start by defining what a digital twin is. A digital representation of a physical asset, process, or system, as well as the engineering information that provides performance and simulation modeling. It could be continually synchronized from multiple sources, including sensors, continuous survey, to represent the near real-time status of the working condition. It enables data-driven workflows, including asset visualization, status checking, and performance analysis and insights in order to predict and optimize systems. With the complexity of the world with all the infrastructure and information coming from data sensors, Internet of Things, and artificial intelligence, and cloud computing is all helping us process the data. We're now seeing a reality of digital twins to aid simulation and immerse digital interaction with all of the available information. When it comes to digital twins, we mean virtual representation of physical assets. Today we will show how our solutions help you create digital twins and manage digital twins. So let's start with a human example. I created a twin of a colleague using context capture cloud services. This can be viewed in virtual reality and look like a twin, but to have complete digital twin, I must need more digital content. How about adding those other sources of information? The skeleton system might represent the physical characteristics of a city, like the database and information coming from SCADA data from sensors and the Internet of Things. From this, we could research information about him at any set point in time with augmented reality. The nervous system and so on. These are all aspects of the digital twin and how the real human might function and react. This would be adding artificial intelligence to simulate what would happen under different circumstances. This is a twin at a particular time. Now, how can we keep a digital twin in sync, and what do we do when things change? For a city, this might include reality mesh automatically generated by photos and LiDAR data. It requires scalable processing capability to handle large data sets, typically needing to cover a full city. Looking at digital twins for infrastructure such as a city or a campus, it gets complicated by the vast amount of information and disparate systems to integrate the data for this visual representation of a physical asset. Reality modeling offers the ability to capture real-world assets with the use of digital photography, point clouds, and integrates the engineering workflow. This is just a few devices that can be provided for input for the reality model, enabling greater accuracy, flexibility, and opportunity. Let's start this example with a street where a camera is mounted on a vehicle. By turning off the color, you can see the mesh where it was created. As we turn the colors back on, we'll see the high level of detail that's available. This could make Google Street View a whole new experience. And it's not just the above ground infrastructure either. Here are some examples of using the street opening as an opportunity to create a reality mesh of the subsurface utilities. With the digital representation of the real world, we can start to layer data to start to bring the digital twin to life. With the complexity of the world, all of the infrastructure information coming from the data sensors, Internet of Things, machine learning, and artificial intelligence, and cloud computing, it all helps us process and use the data. There are over 9 billion sensors around the world today, and we are carrying and wearing some of them. All of us are instrumentating ourselves with our smartphones, smartwatches, Fitbits, and so on. Leveraging the digital twin and all of its data, we can plan, design, construct, maintain our digital world, connecting all the assets and the habitants in real-time information and simulation for proactive emergency and growth planning. As a couple examples, enhanced street modeling from vehicle-mounted equipment. We can use machine learning, artificial intelligence to search a model for possible repair and inspection, looking for potholes, cracks, or broken equipment. As you can see, on the left is what we used to get from aerial imagery, and on the right is what we get from mobile mapping. CityLab's 4D GIS and traffic modeling allows us to model the traffic from cars and devices. This is coming from all of the cars, GPS locations and phones and trafficking, showing exactly how the traffic is changing during the different hours around the world. Using context capture for continuous acquisition of reality data from drones, laser scanners, high-resolution photography, combined with tag data and information about the operating context, the performance of digital twins are continually updated. New capabilities in context capture uses machine learning to more effectively identify and document brownfield conditions and specifically link that asset information. Through our source with iModel.js, we can leverage digital context to display a rich semantic information about what is found in city GML, GIS, or BIM models and sensor networks. Connected intelligent city infrastructure requires connected data environments that manages digital components and digital context to ensure digital workflows through the city infrastructure lifecycle. By bringing IT, OT, and ET together, we can create true intelligent and connected digital infrastructure, supporting planning, design, construction, operation in a smart city environment. OpenCity's connected data environment enables cities and its ecosystem going digital, from planning through design, construction, to operations in the city infrastructure. Now I invite you to watch my session called Digital Twins, Living the New Paradigm of Digital Transformation, where I walk through the complete life cycle of digital twin for infrastructure. It's a fast-paced showcase of how digital twins for infrastructure are in play today. Lastly, let me use this video to illustrate the scalability of reality models, where we built an entire city model from 2D photos.